so on the factoring the math knowledge question, once everyone is finished, you can unpause the video and then I'll go over the correct answers. For the factoring, you're going to factor out a negative first off, and then you're going to factor it as x cubed minus 5, and then x cubed plus 3. And so that would be as far as you can factor this one. For the math knowledge question, we've got two squares. One, I'm going to pick sides of 1, 1 and square root of 2. And then the other one is a square that is L meters longer. And we want to know, how does the diagonal get changed? Well, the diagonal is going to be the square root of 2 times L meters longer, because you just multiply your diagonal by the square root of 2 L to get the next one. So we're looking at lesson 89 today, the average value of a function and the mean value theorem for integrals. So we looked at the mean value theorem from lesson 85. So now this is going to be for dealing with integrals. So hopefully you'll understand the average value of a function and the mean value theorem for integrals after this lesson. So the average value of a function, if you have a continuous function on the closed interval and b is greater than a, then the average of your function is given by 1 over b minus a. That is the length of your interval. And so then you're going to take that and multiply it by the interval of your function. So I'm going to do a picture here. We're going from a to b. I'm going to actually plug in numbers. I'm going to say 1 and 4. So this distance here would be a 3. And we're going to have a function. And this is the area here, because that's what your integral gives you. It gives you the area under the curve. And then you would just take it and divide it by 3 to figure out what the average value of your function would actually be. So that's why you do it 1 over. It's really just find the area and then divide it by the length of your base of your function, basically. So we want to find the average value of the function on the interval from -1 to 2 when we have x squared minus 10. So we're going to say 1 over 2 minus -1, and we're integrating from -1 to 2 of x squared minus 10 dx. And so now we're just going to integrate that. We're going to have 1/3 x cubed minus 10x from 2 to -1. So you're going to plug in a 2. Minus, and plug in a -1. And so now we simplify it. We have 1/3, 2 cubed times 1/3 minus 20, and then minus -1 cubed is -1, and then times 1/3, and then we have plus 10. I'll leave both of those sets of parentheses, I don't guess. So now we can say 1/3, we have 8/3 minus 20 plus 1/3 minus 10. So 8/3 plus 1/3 is 9/3, which is 3 minus 30. So 3 minus 30 is -27 times a third would be -9. So the average value for our function is a -9. And that's how you use that function. Looking at this one, we want to approximate the average value of the function. When it says approximate, what does that mean we get to do? We get to use the calculator. So we are going to do 1 over 3 minus 0, because those are our endpoints, from 0 to 3, and then 4e to the 2x dx. And it says approximate, so we get to plug that into our calculator. So we're going to look at our calculator. and we're going to plug this function into it. So I'm going to say 1/3, and then I'm going to integrate. Whoops. You go to math, and then we're going to function integral, and our endpoint is 0 to 3, and then our function is 4e to the 2x, and then with respect to x. And so if you use your calculator, you should get the same number I get, about 268.2859. And so that's how you would do that one. And you only got to use the calculator because it said approximate right here. If it had said to find the average value and it didn't say approximate, you would need to integrate it by hand and then leave it in terms of e. Okay, so let's look at the next part, the mean value theorem for integrals. So if f is continuous on your interval from a to b, then there exists some number c between a and b such that f of c equals 1 over b minus a, and then you integrate from a to b of your function. Now this part here should look very familiar because that's the average value that we just looked at a minute ago. And so the mean value theorem for integrals just says that if you have a continuous function, there's some number between your a and b that gives you that average value. So let's look at an example. We have that the average value of our function, 2x cubed, on the interval from 0 to 3 is 27 over 2. Use the mean value theorem for integrals to find some number c such that f of c equals 27 over 2. Now the book says the mean value theorem for integrals cannot be used to find the value. It only tells us that it exists. It says there exists a number c between a and b such that it's true. It doesn't tell you that you can find it. So given that it is telling us to use the mean value theorem for integrals to find the number, we can't actually find it. We using the mean value theorem because it only tells us that it exists. So if we actually wanted to find it, you would need to use algebra, and it tells us that the average of our function is 27 over 2. And you would basically set that equal to your function 2x cubed. So if you divide it by 2, you have 27 over 4. And then you would take the cube root, and whatever number that is what your c would actually be. But you can't actually use the mean value theorem here to find your c. It only tells you that it does exist. Okay, so that's how you use the mean value theorem for integrals. You do get to omit number 3, 5, 14, and 16 on your homework, so make sure that you do those tonight so that we can go over any questions you have tomorrow.